So far, we've been testing our components by dropping them onto the individual actors which are already in the world. In this module, we're going to see how we can create some new components in an actor class and then attach them depending on their type using C++. So some of this will already be familiar to many of you, and to some people you may have worked with things like this and just never really considered what the differences are, the nuances, and some of the things you're even looking at. So just a quick recap what we're going to be looking at. In the level at the moment, you'll have things which should look a little bit like this with a few different components. So remember that the cube is actually a static mesh component, which is a type of scene component. It has a transform. It also has the primitive component properties of being able to render something and create collisions. We then have the health and the destruction components, which are the custom actor components, which in turn do not have that transform. Now, something you may not have noticed or considered before is that these actually have their very separate groups here. You can see the actors are down below underneath this line just here, and the scene components are above. So they've kind of been categorized in a different way as well. Now, if we go into the demo actor just to show this a little bit more in depth, again, we can see here we already have a cube, which we'll be replacing in just a moment, but this is the static mesh component. In the viewport, this means that if this wasn't the root component, because this is the base of our object, we would have the option to move this around. We can still see that we have the scale transform though, and if we go ahead and add another scene component, we do then get this transform that we can grab, move around. So we can then scale this, rotate this, and move the location as you would expect. Now, if we go ahead and add another actor component, so we'll just pick one that we've created. So let's go ahead and get our floating movement component. You'll see that this has been dropped again below that line just here. This doesn't have the same details. We can't grab this in the viewport. It doesn't have any kind of understanding of a transform or how that could be placed. So these are the differences we're looking at. And another thing that we can see here is remember that scene components can be placed onto actors, or they need to be placed on an actor, but they can also be nested onto other scene components, as we can see here. So we can have a stack of different scene components all being nested onto each other and inheriting the parent component's transform details. So I'm just going to get rid of these. We're going to want to control all of this in our C++ code. So make sure that you have the same kind of setup here. We're actually going to get rid of the cube in a moment as well. But I'm going to leave that just to show a quick demonstration when we have included this in our code setup. And with this open, there's just a few things we're going to take a tour around before getting started with working with this class. So I've created a few implementations inside of this class to begin. So the first thing is I've included the public eye health interface. So this is an interface created just for this project. If we navigate to this, I'm just going to go to the declaration, and quite simply, this is an interface with a single function declared here. We've made this a Blueprint native event so we can easily update and work with this inside of Blueprints, and it's Blueprint callable. And as it says just here, we don't add the functions to our interface classes. So if I just hop over to the class, this is a completely empty interface class. So what we're going to do is we're going to take this health depleted function, and back inside of our demo actor class, that's why we have this void health depleted function here. This is where we're going to inherit this. So anytime you're using an interface, you need to have declared the same function in the class that you're using that interface on. Then in our code file is where we're going to actually be using the health depleted implementation, because remember it was that native event. And all this is doing quite simply is destroying the actor that this is placed on, just for some kind of very simple demonstrations. So that's the main thing to be aware of. Besides that, it is just an empty actor class. So what we need to do now is we're going to go to our protected section, and we want to begin adding our components that we're going to create in our code file. So the first one is we want to replace that cube that I've just added in Blueprint, and we're going to make that a root component in C++. And that's going to be a uStatic mesh component named mesh. Then just above this, we can give this a U property, which will take in the edit defaults only and be provided a category named components. With that created, I'll just take a copy of this, as we'll use this in just a moment, and then I'll drop down another line and we'll create a health component, as I think every actor will kind of benefit from having a health component just so they have the idea of having that health system implemented. So this will be using the uHealth component named healthcomp. And again, I'm just going to jump up a line and then paste that U property just there. And then to stick with that idea of creating the possibility of having that kind of emergent gameplay where everything can have a concept of health, everything can have a concept of being destroyed and doing different things when it's destroyed, we'll also add a U destruction component named destruction comp. And again, we'll set the U property to be edit defaults only in the category named components. Now, I should have done this just before because I'm using Rider. If you don't forward declare the things that we're going to be using, it will automatically include the full file path. So either include the file path as you can see here, or my preferred way of doing this would be to create the forward declaration for the destruction component, the health component, and the use static mesh component if that's needed, although I think in this case we can get away without that one. So with those four declarations included, I'm just going to go ahead and delete the two file includes up here, and that will just keep things a little bit neater and a little bit lighter on the performance. And of course, we need to include the U just here for the component types. Okay, so with that done, we're going to jump over and we're going to start looking at the code, which will be kind of unique to the actor and the scene component when we're creating them, and some of the things that we can do with this. Now, this can be a fairly basic step, but again, having the understanding of these steps that we need to take is going to be very, very important for the future modules where we go into some of the more complex components which have already been created for the course and looking at how they work and how they've been implemented. So by far, the easiest type of components to include or to create is going to be our actor components. Now we need to create any components in the constructor. So we're going to do this in our demo actor constructor here. And we can create our health and our destruction component to begin, as this is just a single function call. So for the health component, this is going to be very simply healthcomp equals create default subobject. We're then going to pass in the type of uHealth component. And this just requires an override of a text type for the name, and we'll just call this one healthcomp. Okay, so nice and simple. If you've never done this before, you've now just created your first actor component inside of another actor class. So if we were to compile this now, that means every version of the demo actor class will have a health component by default. Now before jumping ahead and running the compilation, we can do the same thing for our destruction component. If you wanted, pause the video here and see if you can do that yourself. It's very, very similar. You just need to change out a few of the arguments here. So of course, all we need to do is we're going to say that the destruction comp is equal to the create default subobject of the U destruction component, and again, provide the text, and this one we'll call destruction comp. Okay, so nice and simple. And with that done, we have now created our first two actor components. So for the scene component, this is slightly different. The first step, we can actually just recreate anything that we've taken here. So we need to first of all create the component. So we'll do that. We've called ours mesh. So we'll say mesh equals to create default subobject, this time of type U static mesh component. And the text, of course, we can just call mesh. Okay, now the difference here is that this creates the mesh, but it doesn't really tell it what to do inside of the actor. It doesn't necessarily know where to place it, whether that's in line with any other scene components, which one is going to class as the root, and that's what we're going to take care of now. So usually when you've created your first scene component or only scene component, what we can do is we can just make absolutely sure that the system or the actor knows that this is going to be the root part of the component hierarchy. And to do that, we just say that the root component equals to mesh. So of course we haven't defined this anywhere. The root component is something that actor classes have in the class hierarchy already, so we can find this in the Unreal code here, so the uScene component type of root component, that knows exactly what it's looking for. And all we're saying is that when you're looking for this, when you want to know what the top thing in the hierarchy is, we're now just defining that the mesh that we've just created is now that root component. So this means if we wanted to add anything else, like the hover components or anything else which is a scene component that we've created, then we can nest that onto the mesh so that any of that kind of transform information will be inherited from the root component. So this is one of the ways that the scene components begin to differ from the actor. We still need to create the component in the same way we've created our actor components. But we then also want to start deciding what we're going to attach it to, whether we're attaching it to the actor class or another scene component inside of the actor class. So I'm just going to check before we go ahead and do our final things. Just need to make sure that we have the correct includes here. So for this, we're going to want to include the health component and the destruction component. And when that is done, when you have those includes ready, again, the static mesh is going to be understood within this type of class, so we don't need to manually include those. What we can do is we can get this compiled and then we can go and check our results inside of the editor. Okay, with that compile successfully complete, we can see immediately inside of our demo actor class, a few things have changed here. So we have our two actor components. We have a health and a destruction component. Now this opens us up quite nicely to adding our ticks here, whether this is explosive, the particle systems, and again, we're going to go into this in more details in a specific module around that component type. But this was just to see how we can get them added to our classes. And then on top of this, we can see as well, we now have a mesh, which is inherited. And of course, if you're unfamiliar with this in the past, whenever you see something saying that it's inherited, this means that we're no longer able to delete it because it's been created in a C++ parent class. So this is going to be on every version of a class, which is a child of the demo actor. Now, the other thing is we have this cube, and this is what I wanted to leave this here for now. Now, because we've told the actor specifically that the mesh is the root component, that means that the cube will default to take the next position in line in the component hierarchy. So with that, that was really all I wanted to show. But we now have our root component and then other scene components added to our root component. So what we can do is we can delete this cube. If you are using the exact same project as me, you probably won't have any other static meshes. If you do, you can use the SM sphere that you have here, or if you wanted to work with a cube again, what I'm going to do is, because I think that sphere is quite small for the particle effects that I've provided, I'm just going to very quickly drag in a cube from our panel over here to the left, and we can right click on this, convert the cube to a static mesh, place this in the correct place in the meshes folder. I'm going to name this one SM_cube, and we now have another cube to work with just to visualize things. We can delete this from our level, that's not going to be used anymore. Now, one thing we want to do is sometimes this won't always come in with a collision setup. So inside of our new SM_cube, we're going to go to collision, give this a box simplified collision. We can see we now have that green collider, which is perfect. And this is going to be important because we're looking for, you've already seen like we're doing traces to check against different things for the hover components. The destruction component is checking for collision traces, so we will need that information. So with that done, we can come back to our mesh, go to static mesh, reassign the cube so it looks pretty much exactly as it did earlier, but we've now defined our own mesh component rather than using that default cube that you get from here, which is still a static mesh, but it just wasn't assigned by us through our C++ class. The other thing is this comes in with the basic shape material. I think I gave this a dark grey, so if you wanted it to look as it did earlier, then we now have everything as it was previously. And just to test, again, the collision is the important thing. We can blow all of these destructive components up, and that is working perfectly. Also, we can see that that is being traced against, so everything is working as it needs to with those changes. Okay, so with that done, we've looked at the way that we can set some of this up. Some of the considerations were kind of a given that we want to avoid things like having two components that would conflict with each other, such as having the hover and the floating movement component on the same actor as are trying to apply movement in different ways, which is why we've gone for the health component and the destruction component for the actors. And then to show the use of scenes, we've added our static mesh component because that was kind of needed anyway for visualization. So you've now seen how you can implement an actor and scene components directly to a class through code. This puts us in a really good position to look through the pre-made components provided in the project, so that we can see other examples of how these components can be implemented into a project.